This is the video demo for project 3 of CPE 329, the digital multimeter on the MSP 432. So the first part of this demo will be testing DC measurements. So we're going to change this to a DC of 1 volt, and we'll see the reflection over here in the measurement of 1 volt, and we'll change this measurement to 2 volts, and we'll see the average moving up to 2 volts. This is part 2 of the CPE 329 Project 3 demo. Here we'll see a 3 volt peak-to-peak sine wave with a 1.5 volt DC offset at a frequency of 500 Hertz. As you can see, we get the DC offset pretty good, the volt peak-to-peak, but the frequency is a little bit fluctuating, still around 500, but there is a decent amount of variation in that. Next, we're going to move on to 1 volt peak-to-peak, and a 0.5 DC offset with a frequency of 1K. And you can see the little reading down at the bottom. We capture that DC offset, and we get the frequency a little bit better there. Move on to the next waveform, which is 1 volt peak-to-peak sine wave with a 2.5 volt offset. And we see that the whole waveform has shifted up. The frequency reading is still fairly accurate, and we see that reflected DC offset change. The next reading is a 3 volt peak-to-peak triangle wave with a 1.5 volt offset. And what's cool about the little viewer down there is that you can see the actual waveform change, and you can see we get the frequency much better with the triangle wave, as it has a more defined max, and that's what we're tracking. You can also see the DC offset. After a small amount of finessing, you can see the last AC voltage waveform demo requested is the 1 volt peak-to-peak square wave with a 1.5 volt offset at 10 Hertz. You can see we get within a hertz of 10 Hertz, and this is the model waveform here on the waveform generator. Now for the last part of the CPE 329 Project 3 demo, the frequency specific part. So this is set at 1 kilohertz, 1 volt DC offset, and a 3 volt peak-to-peak at 1 kilohertz, and you can see the frequency reads almost exactly correct. And now we'll move on to the low end of the frequency spectrum here. So I'm going to step down the frequency and give it some time to adjust. And finally to 1 hertz. Now let's grab onto the waveform, and you can see the frequency average start to drop. And that's at the triangle wave. And now we'll switch over to a square wave. And you can see the frequency remain constant at 1 Hz reading with this square wave.